This is Math 990, Module 5 Review, the second video. So we're going to start with number 17. This is one of those problems that can look a little bit intimidating because of those negative exponents. So all we're going to do is we need to rewrite it with positive exponents. So if you remember, a negative exponent is just basically saying it's in the wrong place. So if it's in the numerator, it needs to come down to the denominator. And vice versa. If it's in the denominator with a negative exponent, it needs to come up. So this would simply be y to the fifth over x to the fourth. So you keep the number the same, you just make them positive. And that's your final answer. Okay, we did a multiplication one. Let's go ahead and do one of these division problems. So we have 35x to the 8th over 2y to the 7th. And now I'm going to make it times because when we're dividing fractions, remember we flip and multiply the second fraction. It does matter, so make sure you're flipping that second fraction. So 11y cubed over 21x squared. And now we need to cross cancel. So I'm going to show you the other way you could do this though if you want to. So 35 would simplify to 5 times 7. 11 would just stay 11. So I'm going to do all those numbers first. We have x to the 8th, 4, 5, 6, 7, 8, and y to the 3, 2. Barely fit it. There we go. Over 2, oh shoot, I'm going to be out of space. I shouldn't have started over so far. Y to the 7th, 3, 4, 5, 6, 7, and then 21. We'll put that 3 times 7 here. X squared. Oh wait. 2, 3, 4, 5, 6. That's funny. For the last one I wrote 7. There we go. So we have 7 y's. 3 times 7 from the 21, 2 from the 2, and then x squared. Got a little... I would recommend being a little more straightforward than I was on the denominator. The top part we were a lot more organized. Okay, now we can go through and just start canceling. So we've got 7's will cancel. We've got 2 of the x's will cancel. 3 of the y's will cancel. Let's cancel out that ugly y that I made. And that's it. So on the top we're going to have still 5 times 11. So 55, x to the 1, 2, 3, 4, 5, 6. So 55x to the 6th over 3 times 2, or 6. The x's are gone down there, so we have y to the 1, 2, 3, 4. So notice it would have been the same if we had canceled in this way, so y cubed minus 3y, so we would just have y to the 4th. Similarly, x squared cancels, we would left with 6x's. And then cancel out here, we could cancel out 7's. So it would work the same if we cross cancel, but if you're more comfortable, you can also write it out. Just kind of gives you another way to solve it, and that's our final answer. Okay, 20, just make sure on these ones that you put each number, each part to the 4th power. So we want 5 to the 4th power and y to the 12th to the 4th power. So 5 to the 4th, we do 5 times 5 4 times, which gives us 625. And then this one will raise 12 to the 4th, so 12 times 4 we get 48, so 625 y to the 48. So not terribly hard as long as you remember that the 4 needs to be distributed into both the 5 and the y. All right, on 21, we need to divide and then we need to write our answer in scientific notation. So first what we're going to do is kind of divide these two together and then these two together. So let's first do 2.916 divided by 8.1. And that gives us 0.36 times 10, times 10. Now up here we have negative 25, so I'm going to kind of write an additional step here. We have negative 25 minus whatever's on the bottom, so we're going to minus a negative 3. Very important that you minus the negative because it's going to really turn into a positive, right? So we get 0.36 times 10, those became plus, so negative 25 plus 3, so it's to the negative 22. Okay, are we done there? We're actually not, because this is not in scientific notation. Our final answer needs to be in scientific notation, so we need to change 0.36. So here's what I would recommend doing. You can do, okay, if we just worried about this part, it would be 3.6, because we need it to be between 1 and 10. So 3.6 would just be times 10 to the 1. Okay, so if we're just kind of looking at that part. And then it's still times 10 to the negative 22. So I would just recommend breaking it into 2 steps. Just take that little part, write it in scientific notation, and then at this point we can combine and say, okay, 1 plus negative 22, so we get 3.6 times 10 to the negative 21 for our final answer. Now, because it wants it in scientific notation, we're okay with negative exponents. On the other ones, you're really not supposed, you really can't, or it'll be incorrect, but scientific notation is okay with negative. So notice we just divided those numbers first. We combined our tens first. We divided the tens. And then when we put this number in scientific notation, we just kind of looked at this separately, and then we put it all back together. Okay, 22, I'm going to skip. 23 is similar, you know, multiply the numbers in front, multiply the tens, and then you may need to rewrite it in scientific notation. Okay, we are going to look at 25. Subtraction's a little bit different, and when I do subtraction, I like to set it up vertically. So we're going to have 6x to the 5th plus 8x squared minus 7x, and then I'm going to line these up. Now, when we have a negative out front, remember it's like a negative 1, and it's going to distribute everything into everything. Basically, it's going to change every single sign. So what was positive will become negative, what was negative will become positive. So negative 1 times 10x to the 5th, that gives us minus 10x to the 5th, minus 9x squared, minus a negative, so plus 8. And I'm going to actually put this over here just so I don't accidentally add the negative 6x and 8, since I know I can't because they're not like terms. So let's go ahead and do that. So 6 minus 10, we're going to get a negative 4. Remember, we're just counting up to the x to the 5th. So if we have 6x to the 5th, we minus 10x to the 5th, we'll have negative 4x to the 5th. Similarly, 8 minus 9 will have negative 1x squared, or just negative x squared, minus 7x, and then plus 8. So that'll be our final answer. I like to do this vertically because I feel like it helps get the negatives all in order, and it helps you see more clearly what to add together. Okay, let's do 28. So 28, you can either just go for it and multiply, or you can also write it out. So like 2 times 5, and then put all the terms together that are going to go together. So x to the 3rd times x to the 10th, y to the 4th times y to the 7th, and then z to the 6th. Let's make sure we've got that. So 2 times 5, x cubed x to the 10th, y to the 4th, y to the 7th, z to the 6th. And now we'll start multiplying. So 2 times 5 is 10. Now just a reminder, since we're multiplying, we can put these together. The way that we multiply when the base is the same is we add the exponents. So it'll be 10x to the 13th. 4 plus 7 will get 11, so y to the 11th, and then still z to the 6th. So this problem, again, it's not terribly hard, but you just need to make sure you're remembering those rules. The rules with exponents might be ones you might want to write down on note cards or something just so you can quiz yourself. Okay, and we're going to end with this number 30. So let's FOIL this out. We have 3x plus 3 and 3x minus 3. So we want to multiply first, outer, inner, and last. Or you can think of it as distributing 3x to both of those terms and then distributing the 3 to both of those terms. So 3x times 3x, we get 9x squared because we're multiplying. 3x times negative 3, we get negative 9x. Positive 3 times 3x, we get plus 9x. Positive 3 times negative 3, we get minus 9. So notice these middle terms, negative 9x plus 9x, cancel out, and we get 9x squared minus 9. So this is an example, this is a special case of a difference of squares. And this is something that will come up later in math, but it's kind of cool. Makes that middle term cancel out. If you have any questions or you'd like to see more examples, please send me an email. I'm available most days to meet over Zoom until 1 p.m. So almost any morning or during your lunch break. So please reach out if you need some help.